Good morning, students. So we have come back to in the classroom of class 10th chemistry, first chapter, chemical reactions and equations. Now we will be in the second part of our discussion. Let us quickly recap what we had discussed in the first lesson. In the first lesson we differentiated between the two terms, matter and substance. Anything that has mass and volume is matter, and when matter is classified according to their physical or chemical properties, we call the classified matters substances. And according to physical properties, we differentiated matter into solid, liquid and gas. That was in the class 9th. According to chemical properties, we differentiated into pure substances and impure substances, and we were dealing with the pure substances, elements and compounds, and mainly in this chapter we will deal with the chemical reactions. What is the chemical reaction? Chemical reaction is the process by which a chemical change occurs. What is a chemical change? Chemical change is that kind of change in which a new substance is produced that we had read in the previous class. Let us quickly recap it through the slides. Please look at the slides once more, then we will come to the next part. Look. So, in a chemical change, the substances that take part, that react with each other are called reactants, and the new substances produced are called products. Now we will learn what is the chemical equation. Let's look at a definition first. The shorthand method, we must write in brief. That is one of the properties of a good chemical equation, well-written chemical equation. It must be very brief. The shorthand method of representing a chemical reaction. What happens in the reaction? We represent it in terms of symbols and formulae. Symbol in case of elements, formulae in case of the compounds. Of the reactants and products, both, is called a chemical equation. Suppose we take a very simple example in the beginning. We are mixing a hydrogen and oxygen according to a certain proportion so that they chemically react. We are writing the symbol of hydrogen and one molecule, the formula of one molecule of hydrogen. In the same way, we are writing the symbol of oxygen and also the formula of that one molecule. And we are also writing the formula of the product. This is unbalanced. We will come to that a little later. But let us take the definition very clearly. Shorthand method of representing a chemical reaction in terms of symbols and formulae of the reactants and the products is called a chemical equation. You see, we have two basic properties of each chemical equation. One is, it must be very brief. And the number two, it at the same time must be informative. We must provide as much information as possible about that process of reaction. Now, before we go to the next part, which is how to write a chemical equation properly, let us see the different kind of chemical equation through a slide. Please look at it. the shorthand method of representing a chemical reaction in terms of symbols of the elements, and formulae of the compounds, and also in the molecules of elements of the different reactants and products, is called a chemical equation. A chemical equation may be of two types: unbalanced, we also call it skeletal, and balanced. Now, an equation in which the number of atoms of different elements, maybe one element or more than one element, the number of atoms is not equal on the two sides of the equation, we call such an equation an unbalanced or skeletal equation. On the other hand, an equation in which the numbers of atoms of each element on the two sides, both sides of the equation, are equal, it is called a balanced chemical equation. The symbols, note that these 3 points very carefully. The symbols and formulae of the reactants are written on the left hand side with a plus sign between them, and the symbols and the formulae of the products are written on the right hand side, RHS, with plus sign between them, and between the left hand side and the right hand side an arrow is put between the reactants and the products, right? Now, there are different ways of writing down a chemical reaction. Suppose we are reacting hydrogen and oxygen. We can write it like this, that a molecule of hydrogen gas is reacted with one molecule of oxygen gas to produce one molecule of water. This is a very elaborate process. We cannot write down all the equations in the world like this, because there are lots of very complicated reactions. There are chain reactions. One reaction leads to another. So we must be more brief, more shorthand. So let us write down the symbols. Say we write down it's like this. Say we give out all the words, just the basic name. Hydrogen, plus oxygen, this is the reactant side, produces what? Produces what? Products. We also call this side left hand side and this side right hand side. This is also brief, and this kind of equation is called the word equation. It is also one way of writing down the basic equation. In the next step, we can go a little further. We can write down the symbol and formula, like hydrogen. Oxygen, that is the left hand reactant side. On the right hand product side, H2O, that is water. This is another way of writing down the formula. We call it skeletal equation. Why skeleton? Skeleton comes from skeleton. Just the bare structure, bone structure. No flesh on it, no blood in it, no body, only the bare bone structure. You see, there is a problem with this formula. We know that according to the, you have read it last night, law of conservation of mass, no matter can be created. Substances, rearrangement of molecules create new substances with new properties. But you cannot create a single atom, nor you can destroy a single atom. You cannot create matter nor you can destroy matter. So law of conservation of mass, it tells us that the total mass, total number of atoms of each element taking part in their reaction must be equal to the number of atoms in each of those elements on the product side. The number of atoms of each element will be same on the left hand side and the right hand side. And that is the problem with the skeletal equation. It is unbalanced. It is not balanced. Look at it. Suppose we know one molecule of hydrogen. It has two atoms. And one molecule of oxygen, it has two atoms. And it produces one molecule of water, H2O. Now, there are two atoms of hydrogen on left hand side, two atoms of hydrogen on the right hand side, that's okay. But how come two atoms of oxygen on the left hand side, one atom is left on the product side? This cannot happen. So we must balance this equation. How to balance? We have to make two oxygen on this side. So we must have two molecules of water. Then we have two oxygen on both sides. Problem is that now you see that once we have made two molecules of oxygen on the product side, now there are four hydrogen atoms, so we must balance on the reactant side by giving two molecules of hydrogen. Now this is the balanced equation. And writing a balanced equation is a branch of study in chemistry by itself. We call it stoichiometry. We'll come to that in the upper process. But let us learn how to write a balanced equation. You must do it mathematically step by step. So let's look at the steps we must follow first. Right? Look at the slide. Please note down the steps. It's better to write down. Pause the video here and write them down. You must follow it step by step. How to balance a chemical equation? First step, write the word equation. Second step, write the skeletal chemical equation. Just the symbol and formulae, unbalanced skeletal equation. Third step, enclose each item, the formulae, in boxes. These boxes will represent a bracket that will remind you that when you put a coefficient before any box, actually all the atoms inside that box are multiplied by that coefficient. Number 4, make a table and list the number of atoms of defined elements on the left hand side and right hand side. I will show you how to make the table. Number 5, now start balancing. Where to start? It is a convention that start with the biggest formula, the compound or the element that has the largest number of atoms in it. Number 6, next balance different elements one by one. And finally, check the correctness of the balanced equation. This is also a very important part. Please note these points down. So these are the steps we must follow while balancing an equation. We will go into that step by step in different examples. But before that, apart from these do's, what we shall do, there are two basic precautions we must take. Remember, these are very vital. Number 1, while balancing an equation, we cannot change subscript what is subscript? Subscript is the number written at the right hand bottom of a symbol, like this two, like this two, like this two. This is called subscript. We cannot change the subscript while balancing the formula. Number one, very serious, because you know what does this subscript mean? The subscript in case of element in the molecule of an element like hydrogen, like oxygen, it denotes the atomicity. How many atoms make up one molecule of that particular element? We cannot change this subscript. And in case of a compound formula, the subscript denotes how many atoms have reacted with the other elements. So we cannot change the subscript, never. And you know that here is also one as a subscript, here is also one as a subscript. We don't write one, but we must take that it is one written. Second very serious rule, what we can do is we can only change the coefficient we can only change the coefficient so long it is a positive integer. So long it is a positive, not zero, not negative, no fractional number. In the final balanced equation, the coefficients can only be positive integers. Like, say we are taking this 2H2O. We did this formula earlier. 2H2 plus O2. We can change this coefficient. Actually, there is only another coefficient here also. That is why we don't write 1. These coefficients can be changed to balance the equation. Let us look at some more equations first, and then one by one we remember these two rules, right? I have already mentioned it specially, but these are very important points, so please also write it down. First point, to make the number of atoms of any element equal on both sides of the equation, we cannot change the subscripts of the formula. Second important point, we can only change the coefficient before a formula. And number third point that we must remember, the coefficient before a formula multiplies every atom of that formula by that number. That's why in the beginning we put each item inside a box, just to remember this point, right? To make a little more clearer, I repeat that you remember in class 9 how a formula is made. Suppose we are writing carbon and oxygen. We now write down the valency of them in the beginning, right? Oxygen is 2 valency, carbon is 4. We cross this and write 2 and 4. So now the formula becomes C2O4 and we cancel out with 2CO2. That is how this subscript comes. In the same way, if we take hydrogen and oxygen, one valency of hydrogen, valency of oxygen is 2. So we cross them and get H2O, O1. That is how the subscript of these formulas come. So we must not change the subscript. Let's take one more example. Nitrogen is 3 and hydrogen is 1. We combine to get ammonia NH3 like this. We cannot change the substitute. And the second point about the coefficient, also remember that when, suppose this one, we multiply the whole formula by the coefficient. When we change the coefficient, actually all the atoms inside that formula are multiplied by this coefficient. These 2 points you must remember, and then let us go to the first equation that will balance step by step. So let's look at the steps once more, please. Let us look at this reaction. Iron and steel reacted to produce magnetic oxide of iron and hydrogen. This is the one equation. Before going to the next part, let me mention here, it is not necessary here, but you can as well know it, that iron has actually 3 oxides. One is, this we call ferrous oxide or iron 2 oxide, because the valency of this is 2. That's why it's called iron 2 oxide or ferrous oxide. And we also have another oxide that is called ferric oxide, or we can also call it iron 3 oxide, because this has valency of 3. Now when we combine these 2 oxides, 2 basic oxides, that is FeO and Fe2O3, they produce Fe3O4, which we call magnetic oxide of iron. This I am just telling you, you can keep it in your mind so that the next part is easily understood. Right? So, let us, you please note it down and then we will come to the next part. Now this one equation, let us change it into skeletal equation. Iron is Fe, steel is water vapor, so it is also H2O. Leads to, we have already seen magnetic oxide of iron, combination of ferrous oxide and ferric oxide. So Fe3O4 plus hydrogen H2. That is the skeletal equation. What is the next? We cannot change the subscript, we can change only the coefficient. So let us put each of these reactants and the products in a box. This box will help you remember that when you put a coefficient before the box, it's like a bracketed identity in the bracket. We must multiply all the elements, all the atoms inside with that coefficient. Next we make a table. Left hand side, that is the reactant side, and right hand side. And here we write the name of the substances that are taking parts. How many substances are taking part here? Number 1, Fe. How many Fe atom is on the left side? 1. How many Fe atom is on the right hand side? 3. Next element taking part is H. How many hydrogen on this side? Reactant side 2. How many hydrogen on that side? 2. Apparently it is balanced, but we will see later. And what is left out? Oxygen. How many oxygen on reactant side? 1. How many oxygen on the product side? 4. So now look at it. We must balance. To balance, we change the coefficient. It is a convention, not a rule. You can start anywhere. But as a convention, we take the largest molecule. The one either in the reactant side or on the product side that has the largest number of atoms. Here it is oxygen. Let us balance the oxygen first. It is less in the left hand side, so we must multiply it with 4. To multiply it with 4, what happens? We must multiply only this is the only component in which oxygen is there. We multiply it with 4. Now the oxygen is balanced. What happened is that because we multiplied H2O with 4, now the hydrogen got unbalanced because it also has got multiplied by 4. So to balance the hydrogen, we also must multiply the right hand side with 4, and here is the product with hydrogen, we must multiply. Now 2 elements are balanced. One left, that is ferrum, iron, if we multiply it with 3, then everything is balanced. So the final formula will be like final equation, balanced equation, like this. 3Fe plus 4 H2O produces Fe3O4 magnetic oxide of iron plus 4 molecules of hydrogen gas. This is the first example. Let us go ahead and see how ammonia is produced. Look at that equation first. Mind the steps very seriously. It must be done mathematically, step by step. Now this is how ammonia is basically produced in nature. Nitrogen or hydrogen, it produces together ammonia. This is the word equation. Let's write nitrogen, hydrogen produces NH. Now what happens? We must, before balancing, we must box the reactants and the products. Right? So now what happens is that as a table we have left hand side, right hand side, substances. There are only 2 substances, nitrogen and hydrogen. Nitrogen 2 on this side, 1 on this side. Hydrogen 2 on this side and 3 on that side. So let us start with the what is more. That is, say, we can start with both, but let us start with, say, nitrogen. We have to balance nitrogen on that side, so we multiply it with 2. Now the nitrogen is balanced, but what happens is that the hydrogen, it has got 2 into 3, 2 into 3, 6 hydrogens. To balance that, this side now has got 6 hydrogen atoms. To balance that, we must also multiply this side with 3. So the final balanced equation will be like this: N2 plus 3H2 raised to 2 molecules of ammonia. Now this is how basically ammonia is produced. Let us look at one more equation, one more reaction, how ammonia is produced in the laboratory. Look at the equation first. This is how actually ammonia is produced in the laboratory. I have written the skeletal equation directly. Magnesium nitrate reacts with water to produce magnesium hydroxide and produces ammonia. Let's balance the equation. First step, we must box each of the identities both on the reactant and product side, so that we remember when we change the coefficient, actually we multiply all the atoms inside that box. Now what we do next is make a table. A table to show substances taking part in the reaction and are produced both on the reactant side, number of atoms on the left hand side, number of atoms on the right hand side. Now the names of the elements taking part in this reaction. Magnesium. Magnesium, 3 atoms on the left hand side, 1 atom on the right hand side. Next, nitrogen. 2 atoms on the left hand side, 1 atom on the right hand side. Hydrogen, actually there are 4 elements in this reaction. Oxygen. Hydrogen, 2 on the left hand side and 2 and 3, there are actually 5 on the right hand side. And oxygen, it has 1 on the left hand side and 2 on the right hand side. Let us start balancing. It is very easy to balance the magnesium. What we have to do is change the coefficient on the right hand side. We must multiply this because this is the only product with magnesium in it with 3. Now the magnesium is balanced. In the same way, it is very easy to balance the nitrogen. Because you see, if we multiply this with 2 and we also must change the coefficient to 2 here, nitrogen is also balanced. Let us look at what happens to the hydrogen and oxygen because of this. Now on the right hand side, there are 3 into 2 and 3 into 2. There are 6 plus 6, 12 hydrogens. 12 hydrogen atoms. Whereas there are only 2 on the left hand side, we must balance it. And what about oxygen? Now 3 into 2. There are 6 oxygens on this side. We must balance it also. Now let us balance the hydrogen by multiplying E with 6. So we must change the coefficient to 6. Now there are 12 atoms of hydrogen on the left side. It is balanced. And what we see, when we change the coefficient to 6, actually the oxygen is also balanced. So the final equation is like that. Ne3N2 plus 6H2O makes 3NaOH2 plus 2 molecules of ammonia. And now we will discuss 2 very vital, important chemical reactions that happen in our daily life. One is photosynthesis and one is respiration. Please look at the formula first. is the most important chemical reaction in nature. You know, the photosynthesis, where the tree, green tree, they take carbon dioxide from the air, water with minerals from the soil. In presence of sunlight and chlorophyll, the green pigment, they produce glucose, a basic form of carbohydrate, food for all of us. And also another important product, oxygen gas, that we must take in, breathe in to survive. So it is the most important reaction in the nature. Let's try to balance this equation. Let's bracket all the identities so that we remember the coefficient multiplies the number of all the atoms inside this bracket. Next we tabulate the substances, the number of atoms of each substance on the reactant side and the product side. How many substances are there? Carbon is there. How many carbon on this side? 1. On the reactant side, 6. Second, hydrogen. How many hydrogen on this side? 2. How many on this side? 12. And third, oxygen. How many oxygen on this side? 3. And that side is actually 8. Let's start balance. Let's balance the carbon first. It's easy because we must multiply the left hand side with 6. That means the only reactant with carbon in it, we change the coefficient to 6. Now the carbon is balanced. What happens is that now the number of oxygen on the reactant side has also changed. Now it is 12 and 1. Now oxygen on this side is 13. 12, 1. So we must try to change the oxygen on that side also. So we change, multiply this one with 6. This will give us 6 into 2 and 6, 18 oxygen. It is still unbalanced. Okay, let's for the time being change the hydrogen. It looks easy also because we must multiply it with 6. That is the only reactant with hydrogen in it. Now there are 12 hydrogen on this side and 12 were already on that side. What happens is now the number of oxygen automatically changes to 12 and 6, 18 on this side. And it is automatically balanced. The final equation is like that. 6 CO2 plus 6 H2O in presence of sunlight and chlorophyll produces glucose and 6 molecules of oxygen gas. Now the opposite. Glucose is produced here, but in our body we take this glucose and burn it with oxygen in our cells to produce oxygen, produce carbon dioxide gas and energy. We call that process respiration. Look at the basic reaction first. This is the skeletal equation of respiration. Now energy in presence of oxygen, it is burnt within our cells to produce carbon dioxide gas, water and also energy. Energy is also product here. But we are not counting energy in our what we are doing here. We are balancing only the mass, conservation of mass on both sides. Let's do it. Let's box each item first. We are not counting the energy in this kind of equation. All the substances, the number of atoms on the left hand side, reactant side, and on the right hand side, the product side. First, carbon. How many carbon on reactant side? 6. How many on the product side? 1. Next, hydrogen. How many hydrogen on this side? 12. How many on this side? 2. Oxygen. Oxygen 6 and 2. 8 on this side. And 2 and 1, 3 on that side. Let's start with the, you see the largest number of atoms. That is the convention, not the rule I am reminding you again. Let's start with hydrogen. If we multiply this with 6, and to make that on the product side, we also must multiply this H2O molecule with 6. Now the hydrogen is balanced on both sides. What about oxygen? Now the number of oxygen on this side has changed to 6 oxygen, 2 oxygens to 8. Apparently the oxygen is balanced also. But let's see. We balance the carbon. To balance the carbon, we multiply right hand side with 6. You see. What happens is that now the carbon is balanced, hydrogen is balanced, 6, 6, 12, 12. But the oxygen has increased on the product side. Now there are 12 and 6, 18 oxygen, whereas only 8 on this side. We cannot change this one. Let us multiply that with 6. So now we got 12 and 6, 18 oxygens also on the left hand side. It is balanced. The final balanced equation will be like this. Six molecules of carbon dioxide, 6 molecules of water plus energy. These are sufficient examples for you to do the exercises I will provide. One or two more points I mention here. One point you will not need directly at this stage of your study, but let's also know that there is one thing called an ionic equation. What is an ionic equation? First, let us look at the definition. First, look. An ionic equation. What is an ionic equation? It is such an equation that not only shows the atoms and molecules, but also it contains the ions that are actually taking part in the reaction. An equation which contains not only atoms and molecules but also contains ions actually taking part in the reaction is called an ionic equation. Sometimes, usually, only the ions of the ionic compound actually taking part in the reaction are written in the ionic equation. And one point you must remember, a balanced ionic equation. It must satisfy the mass balance. The mass must be balanced on the reactant side and the product side. And also the charge balance. The total charge, net charge on the reactant side and the product side must be balanced also. Right. You will not need it in class 10th level, but as well you can know that there is another way of writing an balanced equation. This is such an equation in which not only the atoms and molecules, not only the mass of the reactants and products are balanced, also the net charge of the reactant and the net charge of the products are also balanced by despite the ions actually taking part in the reactions. Mention only the ions taking part in the actual reaction, and that kind of equation is called ionic reaction. Sometimes we write only the ions taking part in it, not the whole equation. Let's give an example and then move to the more important part, which will be important for this class. We'll go on that. Let's say zinc, which is solid, it reacts with CuSO4 is aqueous solution. Aqueous solution of copper sulfate is an ionic solution. Right. And it produces, say, zinc sulfate, which is also aqueous, and copper, which is solid. Now, if we write the ionic form, it will be like this. We know that this Za, it is actually plus 2 ion, and this Cu, it is also plus 2 ion, and SO4, it is actually minus 2 ion. So when copper sulfate, it is in the aqueous solution, it gets divided into copper ion and sulfate ion. So the reactant side will be like this, plus Cu plus 2 plus SO4 minus 2. So what will be the right hand side? Now zinc sulfate, zinc is in the aqueous solution. So zinc is now sulfate minus plus copper is now solid. Now look at it. On the both sides, this is common, the sulfate minus 2 ion. We can cancel these two out and write the whole formula like this. Za plus Cu plus 2 produces Za plus 2 plus Cu. The net charge is plus 2, which is balanced here. This is called an ionic equation, balancing the net mass with the net charge. You will learn it later on, but let us now go to a more important part, that is how to make a chemical equation more informative. First look at the points I want to make with the definition of catalyst. What is a catalyst, right? Let's do that.
Yes.
These points you also must note down carefully to make the chemical equation not only brief but more informative. We must state wherever is possible. First, we must state the physical state of the reactants and the products. Like this, in this equation, we see that zinc is reacting with sulfuric acid to produce zinc sulfate and hydrogen. We are pointing out the state of the reactants and products in the bracket. Zinc is solid, sulfuric acid is aqueous, it is the diluted, we can also write diluted. Zinc sulfate is also aqueous solution of salt solution aqueous, and hydrogen, you see, it is gas. Same way, we must point out the concentration of the acid, whether it is diluted or concentrated. Like in the previous example, the sulfuric acid was diluted. Here is an example. Copper, it is solid, reacts with nitric acid. It is concentrated. Otherwise, the reaction will not take place. So, CONC full stop, that is concentrated. It produces copper nitrate, aqueous solution, and nitrogen oxide, that is gas, and water, which is liquid. Number 3, we know that heat is often absorbed or released during a reaction. This heat changes accompanying the chemical reaction, whether it is an exothermic or endothermic. We can also indicate it. In an exothermic reaction where heat is released, the heat is written on the product side. And in the endothermic reaction where heat is absorbed, we write the heat on the left hand side, that is the reactant side. The first example is exothermic. You see that methane gas and oxygen gas, it produces carbon dioxide gas and liquid, that is water, and releases heat. Second one, nitrogen gas, oxygen gas, it absorbs heat, endothermic, to produce nitrogen oxide. Number 4, conditions under which the reaction takes place. Sometimes there are specific conditions. Like you see, this carbon monoxide gas, it reacts with water only when there is 300 at atm, that is the pressure, atmospheric pressure unit, and also the temperature must be specific 300 degrees Celsius. Otherwise, this reaction will not take place. And also we must use zinc oxide and chromium oxide as catalyst. We are coming to that to produce the CH3OH, which is liquid. Now, about this, what is the catalyst? We must specify this. Let's look at the definition. A catalyst is a substance which increases the speed of a chemical reaction without being consumed. It does not react itself, it does not change itself during the reaction and is recovered chemically unchanged at the end of the reaction. It is the same at the beginning of the reaction, at the end of the reaction. It does not take actual part, but it helps increase the speed of the reaction. Like you see the next example, we have already seen that here the catalyst is zinc oxide and chromium oxide. They remain unchanged, but they help increase the speed of the reaction. Same way you have seen that in the photosynthesis, actually chlorophyll, it works as a catalyst. Chlorophyll does not change itself, but it helps the process of photosynthesis. And in that sunlight is also a necessary condition, because photosynthesis can take place only when sunlight is there. This is the way we must be more informative while writing a chemical equation. It makes it better, right? So students, you have learned a lot in this class. So please go through your book very carefully about the relevant part. Go through all the steps I have followed methodically, and come back to the next period in which we will now discuss different kinds of chemical reactions. How many kinds of chemical reactions there can be, and what are some daily examples of these chemical reactions in our life. For that, we need one more period, but this period has been the most important period because you have learned the basics of stoichiometry in this period. I will be providing you some unbalanced equations, which you must step by step follow and balance them before coming to the next class. Till then, stay home, stay safe, and please enjoy your study, but don't waste time. Thank you.